Today's topic is called factoring quadratic expressions. We're going to look at one particular method today. This is not the only method, and it's not the method that's going to be in your book. So if this doesn't work for you, there's a method in your book. You've probably already seen a different method, which is fine. If you're good at these other methods, that's fine. Use those. But if every other method you've ever seen doesn't work for you, or is too hard for you to remember what to do, then you might really want to give this one a try. This method comes with different names. Some people call it the Canadian method. Some people call it the Australian method. Some people call it the area model. I just call it the AC model. And you'll probably hear me use the phrase area model, and you'll see why here in a bit.
It doesn't require a calculator, does it?
It doesn't require a calculator, although sometimes the arithmetic it's helpful to have one. I think we'll probably get through everything today without one, actually. So we're going to factor things that look like that. Now this slide is going to fill up. It's going to have a whole bunch of information on it, and it's going to make it look like that we have to do a whole bunch of stuff to do this. But most of what's on this slide is explaining what we're going to do. When we actually do these on the other slides, you're not going to see near as much stuff on the slide. We're just going to do the problems. So we're going to factor 3x squared minus 16x plus 5. We're going to try to break it down into its two binomial products. And there's some steps that I've outlined that we need to get through to do this. So again, I'm going to refer to this as the AC method. Okay, the AC method. Question? Binomial is a two-term polynomial, like x plus 5 or 7x minus 3. Those are binomials. This is a trinomial. It's a three-term polynomial. First step is it helps to have this in standard form. So you're going to put everything in the standard form, ax squared plus bx plus c. The main reason you do that is just so that you're finding a, b, and c. So just like if you're going to use the quadratic formula, it helps to know where a, b, and c are. The next thing you need to do is find the product a times c. So for this problem, what's a times c? 15. 3 times 5 is 15. So we've got the 15. We need to identify b. What's b in this problem? Negative 16. Okay? And then we're going to look at all the possible factors of AC. In this case, we've got 1 and 15, negative 1 and negative 15 would also make 15. 3 and 5 and negative 3 and negative 5. From that list of factors, we need to find the two that add up to b. Yeah, negative 1 and negative 15 add up to b. We've done the hardest part of the problem. It's done. The hardest part of doing this is finding these two numbers. If you can find these two numbers, everything else just falls into place. That's the coolest thing about this method. Do you remember it? Okay. As far as I know, there's only one other teacher here that teaches this. He's next door. Okay? So, now we go ahead and we set up the box. This is where the area model part happens. How many terms do we see in the original problem? 3. We got 3 boxes, though, or 4 boxes, so that's kind of confusing. What we're doing, though, is we're splitting the middle term into two things. Negative 16x is the same as a negative 1x and a negative 15x come from these two numbers, right? So in the first box, we put the first term, the 3x squared. In the last box, counting just like we read 1, 2, 3, 4 across and down, the last box is going to be the last term is the 5. In the two boxes in the middle, we're going to put the negative 16, but we're splitting the negative 16 into these two numbers, negative 1 and negative 15. But that's not just a negative 16, is it? It's a negative 16x. So we're going to put a negative 1x in one of the boxes. We're going to put a negative 15x in the other box, and that's going to represent our negative 16x. It doesn't matter which box we put them in. You can put them in either box. You can reverse it around. So that's kind of cool, too. I chose to put the negative 15x in the lower box and the negative 1x in the upper box. Yep. It's got to be there. Because these two values on this, we're going to call it the rising diagonal, going from left to right. On the rising diagonal, the negative 15x plus the negative 1x have to add up to that negative 16x. They have to. And so they both have to have an x to do that. What's that? Negative 1 times negative 15 is one of the factors of 15, but it also adds up to the negative 16. Okay? From here, looking down the first column, we're looking at the 3x squared and the negative 15x. What can I factor out of 3 and 15? How about 3? I call it the AC method, but we're factoring that trinomial. What can I factor out of x squared and x? X. So I could take a 3x out of both those numbers, right? Both those terms. What would I have to multiply negative 3x by to get the negative 15x? Negative 5. I'm going to put a negative 5 right outside here. What would I have to multiply 3x by to get a 3x squared? Just an x. Okay? 3x times x is 3x squared. This is why some people call it the area model. Area is for rectangles is length times width, right? If I take the length x times the width 3x, that is 3x squared. It's the number that's inside. If I take the length 3x times the negative 5 width, I get negative 15x, the number inside. That's why they call it the area model. Going for this last hole here, I have x times what would give me negative 1x? Negative 1. And this is a quick check. It's not a proof, but it's a quick check. Negative 1 and negative 5 multiplied together have to make that last number. If they don't, something's wrong. If they do, it doesn't prove that it's right, but if they don't, something's definitely wrong. And they do. Pardon me? Yeah, because remember area is base times height, length times width. Our answer is sitting right on the edge of the boxes. That thing factors to 3x minus 1 times x minus 5. It's factored. It's done. So let's walk through this example. This time I'm not going to write so much, and in fact we're not going to use the computer generator. We're going to generate it ourselves. So some of you guys were writing down the steps, and some of you guys weren't. That's okay, because there's really not that many steps. Those of you that didn't write down steps, can you recall the first step that we need to do? Find AC. Well, I did something before that, but we don't really need to do that this time. What was the... Yeah, just get it in standard form so that it's easy to identify A, B, and C. My board doesn't want to work. Sometimes when I do this, it fixes it. So I'm going to pause this real quick. All right, so I'm going to make sure it's in standard form. It is. Now I'm going to find AC. So A times C this time is what? 24. I'm going to identify B. B is 11. A is 2 and C is 12, so if we multiply them together. Okay, now I got to find two numbers that when I multiply them together I get 24, but when I add them I get 11. Can you think of them? 3 and 8. Okay? So I don't have to do the whole list. I only do the list if I can't think of them. I just start writing the list till I can find them. So since I can see them, that's all I need to do is do that. The hard part's done. Finding those two numbers is the hard part. Okay? We'll go ahead and make the boxes for the area model here. What goes in the first box? 2x squared, and I always write the last box, which is the 12. The 11x gets split with a 3 and an 8. It doesn't matter what number goes where. What number do you want to put down here? 3x. Make sure the x goes with it. And the 8x. Oops, 8x. A quick check would just be to make sure, at this point, make sure that on this diagonal, those numbers add up to b, 11x. The actual whole b, right? The b term, the linear term, 11x. So we look down, we look down that first column, and we say, what can I factor out of a 2x squared and a 3x? X. We can always take out something, and it's always going to be x, right? Because there's always going to be an x there. But what do I need to multiply by here to get a 2x squared? A 2 and an x. 2x times x is 2x squared, right? What do I need to multiply by here to get a 3x? 3. 3 times x gives me a 3x. Now I'm looking this direction. So 2x times what gives me 8x? 4. And quick check, 4 times 3 should give me that 12 at the bottom, and it does, right? So I've got an x plus 4, everything's positive, so we just put a plus sign in there, and a 2x plus 3. It's factored. Okay, he's asking a question, and 3 other people are talking.